Hi folks, this is Calc 2 Take Home 10. We're asked to find the area between these two polar curves. So the first thing we need to do is sketch a good picture of these two polar curves. So I'm going to look at the corresponding rectangular curves, 1 minus sine x. I haven't messed around inside with the x at all, so I still have my standard quarter marks of 0, pi over 2, pi, 3 pi over 2, and 2 pi. I substitute in the 0, I'm up at 1. Substitute in the pi over 2, I'm at 0. Substitute in the pi, I'm back at 1. At 3 pi over 2, I'm up to 2. And at 2 pi, I'm back to 1. I connect the dots in a pleasing fashion. Alright, so let's see what this polar curve looks like. From 0 to pi over 2, the radius starts at 1, r starts at 1 and pulls back into the pole. So it does something like that. From pi over 2 to pi, it goes back out to 1. From pi to 3 pi over 2, it goes from 1 out to 2. From 3 pi over 2 to 2 pi, it goes from 2 back into 1. So this is one of those cardioids. For the next curve, r equals negative sine theta. Let's look at y equals negative sine x. And that's just an inverted sine curve. With an amplitude of 1. So you have the same quarter marks as we have up there and connect the dots like that. So between 0 and pi over 2, it goes from 0 to negative 1. And then back into 0. And then at this part it starts to duplicate itself again. Okay, so that's really what we have. So if I draw a better picture of this, I think, I'll draw this curve in blue. So it's one of these cardioids. Didn't really do that good of a job. And then inside here we have that. So the area we're concerned with is the area between these curves. Okay, so how can I determine that? Well, I can find the area inside the first curve and then subtract that from the area inside the second curve. Now, the area inside the second curve, that's a circle. So the area inside r equal negative sine theta, I can find that using geometry. That's just pi times the radius squared. The radius of this little circle, since the diameter is 1, so the radius is 1/2, so I just get pi over 4. If I want the area inside this curve, then I can just take 1/2 the integral from 0 to 2 pi, 1 minus sine theta squared d theta. Okay, so that's where the bulk of the work is going to be, is computing this integral. Once I find this integral, I'll subtract pi over 4 and then I'll be done. So let's look at this integral, 1/2. Excuse me, integral 0 to 2 pi, 1 minus sine theta, quantity squared d theta. first thing I need to do is expand the inside there. 1 minus 2 sine theta plus sine squared theta d theta. Then I can split this integral up. 1/2 integral 0 to 2 pi 1 d theta minus 1/2 times 2 integral 0 to 2 pi sine theta d theta plus 1/2 integral 0 to 2 pi sine squared theta d theta. I can dispense with these first two integrals pretty quickly. The integral of 1 d theta, I'm just going to get theta from 2 pi to 0, so that's just going to be 1/2 of 2 pi, which is pi. Here I'm integrating a trig function over an entire period. Anytime you integrate a sine or cosine over an entire period, the area is going to be 0, or the integral is going to be 0. The area above cancels the area below. So that's quick to deal with. What do we do here? We use our power reduction formulas. So sine squared theta is going to be 1/2. Combine that with the 1/2 already out front. You get 1/4 integral 0 to 2 pi 1 minus cosine 2 theta d theta. So I get pi plus 1/4 integral 0 to 2 pi 1 d theta minus 1/4 integral 0 to 2 pi cosine 2 theta d theta. Now, once again, I can dispense with these integrals pretty quickly. I have pi plus, this is going to be 2 pi over 4, that's pi over 2, minus, now cosine 2 theta, one period of cosine 2 theta is from 0 to pi. Here I'm integrating over 2 entire periods of this cosine function. The area above cancels the area below. That's just going to be 0. And so I get 3 pi over 2. So the area inside that cardioid is 3 pi over 2. So my final answer then is, I have to take the 3 pi over 2, the area inside the cardioid, subtract off the area inside that circle, pi over 4. So I got to get myself a common denominator. This would be 6 pi's over 4 minus 1 pi over 4. I get 5 pi's over 4. And that'll do it then for take home 10.